A very good morning, good afternoon, good evening, and at whatever time you are joining us for this particular webinar session. Uh, Feel very much welcome. Thank you so much for taking your time to sign up for this particular Pioneer event session. Thank you so much for also creating time to join in for this live stream webinar session. We feel very much humbled. We acknowledge your online presence. We acknowledge that you've tuned in for this particular session. And we're hoping that you shall be able to get to enjoy the session that is ahead of us. And for today's session, we will be discussing on quite an interesting topic, a topic that is less discussed, a topic that is crucial when it comes to getting to improving our effectiveness and efficiency as data professionals. And today's topic is titled Moving from Research to Production, Organization, Tools, and the Workflows for the Modern Data Scientist. And once again, thank you so much and very much welcome to Pioneer Nairobi, this live stream webinar session, and also to the deeplearning.ai community. Um, Today's session and event has been facilitated in partnership with the Alan Turing Institute, partnering with deeplearning.ai, and this is a meetup that has been hosted by our community. So what do you expect to hear from this? What are expectations for this particular webinar? We will get to hear a welcoming greeting video from Dr. Andrew NG. We'll get to hear what exclusive message, what message does Dr. Andrew Ng has in relation to this particular meetup that we're in today, and also from the deeplearning.ai team. More to that, we should all be getting quite excited and getting ready to be able to have a 1 hour full session to hear from our guest speaker, who's we're quite humbled to be hosting him today. He's joining us remotely from Berlin, Germany. He'll be taking us through this particular lecture session that is moving from research to production, taking us through what he has prepared in store for us. And also what we should expect is that after this event session, we shall be getting to hear from the deeplearning.ai, and we should expect to receive 2 follow-up emails. The first email will be an email with detailed instructions on how we should be able to fill the survey form to be able to redeem the deeplearning.ai courses, the courses. And also the second email will come a few days after you filled that form. So please ensure that after the event session, you will be able to receive an email, get to fill the survey form. And then after a few days, please check out a second email that will have detailed instructions on how to redeem the codes so that you can be able to access the deeplearning.ai courses on Coursera. And also, please do ensure you tune in for the event all the way to the end, because we shall be having a full networking hour to get to share amongst each other what we've learned from the session, what our learning objectives met, and also sharing what we're doing in relation to working on our personal projects, working on complex machine learning projects, both at personal level and also at the industry level. So we'll have that opportunity to network amongst us and share amongst us. So please do ensure that you stick all the way to the end of the event session. So with having a full understanding of what we expect for this particular session, we're going to get to appreciate and realize that we could not have been able to have this particular event session coming up today were it not for this amazing team of highly dedicated organizers that have worked around the clock to stitch together the various elements of the event. They've also ensured that they've been active to ensure that they have prepared, they have planned, and now to today when we're now getting to convene this particular event session. And we get to appreciate, we have Griffin Ochieng. He's a healthcare data scientist and a deep learning data ambassador based in Kenya, we have Nicholas Musau, whom most of us will be engaging with him on the YouTube live chat. He's an AI researcher focusing on data governance and security. We also have Ramesh Sharma, who is an AI researcher and also a deep learning.ai ambassador joining in from India. And we have myself, that is Kennedy Wangari. I'm a data scientist working with a transport and logistics company based here in Nairobi, Kenya, and also a deep learning.ai ambassador. And I'm always passionate when it comes to tech communities, AI innovations, and I believe we'll get to have a fruitful and engaging and interactive and highly informative session. So having understood what our expectations for the day, we'll just have a brief history of what deep learning.ai is. For those of us who might not, maybe this might be the first time, we get to understand that deep learning.ai was founded by Dr. Andrew Ng. Dr. Ng is one of the global AI key figures. He's been a great educator. He's been an AI researcher, social entrepreneur. And I believe most of us have been able to kickstart our machine learning careers through his courses. He's also been a co-founder at Coursera. And the main mission and the vision of deep learning.ai is to ensure that they are democratizing AI education and making sure that this world-class AI education is accessible to each and every one of us across the globe, so that we can all be able to learn and build innovatively with AI, and more to that, to be able to benefit from this AI-powered future. So having had that brief history of what deep learning.ai is, we did mention that we are in a Pi and AI meetup session. So a brief history of what Pi and AI meetups are is that this is a program that was initiated early last year by Dr. Andrew Ng, is a way of amplifying his vision of ensuring that the world-class education is accessible to almost everyone. And when you talk of Pi and AI meetups, these are global series of deep learning.ai meetups. So far, we've had meetups held in over 45 countries and over 100 events. And these meetups, like the one we're in today, is being hosted by a team of ambassadors from Nairobi, Kenya, and from India. And basically what happens in these meetups that are held in the various countries, like we've mentioned, over 45 countries, is that they seek to bring together the global AI community. And they heavily involve conversations with thought leaders in the AI field, getting to have that knowledge sharing platform, getting to be able to engage on data science and machine learning practices, and also getting to provide that opportunity so that we're able to learn, we're able to network, we're also able to come together, form common grounds, and to be able to tackle complex problems in AI. So that's a brief up of Pi and AI meetups. And if you're in a city that has yet to be established a Pi and AI meetup, I would also be great for you to also get to join the Pi and AI meetups program by deep learning.ai. So having had that brief history of deep learning.ai, its vision, and the Pi and AI meetup like we're in today, we'll get to briefly share with us the social media hashtags for this particular event. These are the hashtags that you could use to steer the conversations on your social media, be it on LinkedIn, be it on Twitter. Get to share with us what is it that, get to share with the larger public. What did you get? What are your takeaways for this event? What are your expectations for this event? What was the most exciting and interesting thing to you? And also I'll get to target deep learning.ai, at Turing Institute, at Paulino, who is now a speaker, at Andrew Ng. Let's keep the conversation interactive. Let's keep the conversation engaging. And also let's share what we will have picked up from this particular event session. So at this point, I will introduce a platform that we are all able to see on the screens. That is the Slido platform. For all the questions that we will be having for this particular topic. Yes, we've mentioned that this topic is less discussed, and this topic is quite crucial when it comes to empowering us as data professionals to being effective and efficient. And I know we do have those questions that we have. Get to use the link on our screens and also the link that has been shared through the YouTube live chat. Get to ask those burning questions that you've always had around moving your work from research to production, around the topics of the day, because we're trying to ask ourselves that we as data scientists and machine learning engineers in our data science work, um, do we always have that consistent coding style? Are our pipelines reproducible? Can we be able to run them on our laptops as well as on the cloud without getting to rewrite them? And are our model servers ready for the onslaught of the million of users who are interacting with our solutions? And if at all we feel that we don't enjoy these tasks with the tools that we work with, this is the best time for us to ask to get to ask those questions that we've always had, the burning questions. And also more to that, you could share with us what are your expectations for the day? What do you expect to learn? What do you expect to hear? What are your expectations? And also maybe you could share with us where you're tuning in from, which part of the world are you joining the conversation from? What do you expect to hear? And maybe if you've had any experience working on any complex machine learning solutions and moving them from research to production, you could probably also share with us. The link is there. You could also leverage on the social media hashtags that we have. And quite exciting for this particular session, because this is an amazing session that it's quite a unique opportunity that through our amazing speaker, Mr. Kamin Polino, this will be a great opportunity for us to get to learn what are the best, what are the simplest, and what are the fastest tools and techniques that will help us to get our machine learning work from research to production. Yes, we've had those difficulties with the tools that we've been working with, the workflows, but then this will be a great opportunity for us to learn a lot. And also through this event session, we'll also be able to get to learn what are those modern ways on how can we be able to organize our code and the project files and all, and also get to learn how do we get to create reproducible pipelines that can be able to work both on our laptops and as well as on the cloud. And how do we also get to install those dependencies in the modern ways? And also, again, a very crucial thing that I'm quite excited personally to learn is how do we get to speed up the model inferences servers by 14 times while leveraging some of the most beautiful and clean APIs in the market. So having had the understanding of what this event session is all about, where we're coming from, Inspire and AI, deep learning.ai. At this particular point, you're going to hear the exclusive message from Dr. Andrew NG, and also get to hear what does the deep learning.ai team has in store for us. And as that gets to happen also, we will also be sharing um, uh, notices and updates from deep learning.ai. Deep learning.ai recently launched an NLP specialization that basically helps you to master cutting edge NLP techniques that helps you to move from basic understanding of NLP techniques to building great NLP systems. And the notice that will be coming up is that the fourth course of the NLP specialization that was launched in June will be coming up on 29th of this month. And the good thing is that for those of us who will, after the event, please ensure that you fill that survey form, because part of the courses that you'll be granted access to will be this fourth course of the NLP specialization. And you'll also be receiving a coupon code that you can redeem for this NLP specialization. So at this point, you're going to hear the message from Dr. Andrew Ng for this particular meetup, and also why he feels that NLP is the most transformational tech stack when it comes to deep learning and machine learning. So let's get to hear what Dr. Andrew Ng has to say.
Hello, deep learners. Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people.
I would also be great for you to also get to join the Pine AI Meetups program.
Offers in AI and navigate their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
The AI field is new, organizations and jobs are still misunderstood, so I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting, and now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Great. At this point, we're going to hear now why does Dr. Andrew Ng really feel that his new set of NLP courses are the best that we have in the market. So just short.
I think that computers being able to understand language has been one of the most amazing advances in AI. NLP has changed a lot over the last several decades. I think that computers being able to understand language has been one of the most amazing advances in AI. NLP has changed a lot over the last several decades. The field has started off using primarily rule-based systems to then using probabilistic systems to now where NLP relies much more on machine learning and deep learning. In this specialization, you learn everything from being able to translate English to French, to understanding if a customer review is a positive review or a negative review, to building a customer service chatbot, to letting a user enter some text and using that to do web search or to do online product search.
More recently, with the rise of powerful computers, we can now train end-to-end systems that would have been impossible to train a few years ago. We can now capture more complicated patterns, and we can use these models in question answering, in chatbots, and in other applications.
A few years ago, these models would take weeks or even months to train. But with attention, you can train these models in just a few hours.
I'm really excited for everyone to get started, to take these courses, learn these technologies, and to go build some great NLP systems.
Great. So as we did mention, is that that will be part of the specializations that we will have access to. So please do ensure you redeem the courses coupon codes, and you will have access to the NLP specialization. So at this point, we're going to get to understand brief of our speaker for the day. And Mr. Carmine Polino, he is a senior data scientist and also a technical mentor, data science for social good at the prestigious Alan Turing Institute. He's dialing in, and he currently lives in Berlin, Germany. And he has previously served as a data scientist at OLX Group, where he has worked on a couple of projects ranging from computer vision, interpretable machine learning, and recommender systems. He has more than 5 years of industry experience as a data scientist, and also over 9 years of experience as a software engineer. And he is an author who has published a book chapter about large-scale distributed graphic network analysis. And he recently collaborated on a state-of-the-art saliency detection technique. He's he's an avid open source contributor, having great contributions and patches to MXNet model server, Tiano, and amongst others. And when he's not working, he loves to take photos. Many other times when he's traveling, he loves taking photos. He loves writing music. He's also a DJ. And more to that, he loves more about machine learning, psychology, and the stock market. And we will be getting to share links on how you can follow him on his blog at paulino.me, also on LinkedIn. So check out on the YouTube live chat for the links. And also his Google Scholar, so that you can also check out his book chapters. And without much further ado, Mr. Polino, Carmine Polino, we're quite humbled. We're quite excited to welcome you, to get to hear from you. You're such an amazing data professional, to get to learn from you. And at this point, we'd like to welcome you to take us through what you've prepared for us on this interesting and exciting topic. So very much welcome, Mr. Carmine. Thank you.
Thank you. Thank you very much, Kennedy. I hope that this setup is actually coming from the DJ part of my career, and it looks fine enough for you guys. So I'll go ahead and share my screen. Great. So today in this session, I would like to talk to you about how to bring your research to production using modern data science tools. And I would like to give you first an introduction where I will give you a sort of a mental framework of what to look for in data science tools and in tools in general. and then go deeper in what tools I prefer and why. So, well, we already had a beautiful introduction by Kennedy, but hi, I'm Carmine. I'm a technical mentor at the Alan Turing Institute, and right now I'm just in the middle of starting my own startup as well through Entrepreneur First, and that's one of the latest news, maybe. And so I want to talk to you about how to choose tools. So tools are super important for us humans, right? So for millennia, they helped us accomplish tasks that were impossible before. In fact, history has actually marked some of these advancements as ages. So the Stone Age actually was called like that because it began with the most basic stone tools made by early humans. And tools have been very, very important throughout history. For example, the invention of the wheel was really a breakthrough in humanity, as well as more recent advancements such as the Industrial Revolution and the internet have essentially started the invention of the internet that started the information age, right? So we always produce tools, and tools actually expand what we can do as humans. But all the time, we're flooded with tools because each smart engineer, each smart inventor of the past has jumped on the bandwagon and created his own tool. So how do we actually select the best tool for the job? And is the tool that we're using right now actually the best tool for the job? And that sparks the question, well, actually, how do we choose tools in the first place? And why do we choose them? Why sometimes we choose the wrong tools? So here is Steve Jobs over the years. And as you can see, it didn't change his outfit one bit. What does that have to do with tools? Well, it didn't do that because he didn't want to take a decision. And decisions take time. So in order to optimize his time, he just selected this classic wardrobe, jeans, turtleneck, and sneakers. And that's it. That's all he wore all the time. Same thing for Mark Zuckerberg and many, many other leaders in the world, especially in the tech world. So if such a simple decision can be hindering during your day, what about, choosing a tool? Choosing a tool is actually, I think, much more difficult than simply choosing an outfit in the morning. And we're talking about research, perhaps months of research into finding the perfect tool for the job and trying out different things and see what happens, because they're not easily to see. It's not easy to see what is the best one for that specific job. You need to go deeper and try them out and see what happens. And so this kind of research takes time. So what do we do instead? Well, we settle on recommendations. And these recommendations, they often come from our colleagues, from our trusted friends, and they're often pretty good. But are they the best? Well, right now, we know that living in the information age, I'm sure you've noticed, there is this kind of echo chamber effect. So when you go to Facebook, for example, you tend to see the things that you like continuously, right? And on a broader scale, you will see this also on Google, for example, right? So developers that are blogging about tools, they probably blog about, the already blog tools, right? They have to know some tool. So there's this echo chamber effect of people continuously talking about the same things. People spreading information like that at talks. Like one of them is quite ironic, is this one. And content often gets reshared. And this usually wins against proper research, right? For what I mentioned before. Also, in companies, there is the adage that says, if it ain't broke, don't fix it, right? Which is totally fair and totally fine. But then sometimes it may stifle innovation. And there are also the factions and tribes that you may find in computer science departments. And so I have my bachelor in computer science, and there was this big debate against Vim and Emacs, for example. And which one, maybe I'm too old, but which one do you use right now? Do you use maybe VS Code or Atom, right? And perhaps you don't like the other person who likes that one specifically. So there is all this thinking in the enterprise that makes it very slow to change. And also the fact that the industry in itself fuels adoption of specific tools. And how does it actually get to know these tools? Well, if there is another industry leader that is already using these tools, well, they probably will adopt these tools already. Perhaps like discarding all of the good stuff that is out there. And marketing plays a role, of course. So the other psychological phenomenon that happens when you try to select a tool is that when all you have is a hammer, everything looks like a nail, right? So during my career, I've seen that in many different instances, which are really funny, and I can't wait to tell you. So, for example, I love SQL. SQL is great. SQL is a language of querying the data and putting data in databases and linking that together. And you can do some complex analysis in SQL. And thanks to SQL, we can query these databases, which have amazing features, such as, for example, storing much more data than you can possibly have in RAM, right? Which could be a problem if, for example, all you're using is Python and Pandas to do your analysis. You cannot fit everything in RAM sometimes. But I've seen in my career that SQL has been used in one case to make a recommender system. And while SQL is great for doing all the analysis, perhaps to build like a knowledge around how to make the recommender systems tend to be more complicated projects. And they, in fact, it's one of the fields of machine learning. And so clearly that was the wrong tool for the job. And why was the wrong tool for the job? Well, because the people who built it, they had this hammer, which was SQL, and they were great at it, but then everything looked like a nail and they could use SQL for everything. And it turned out to be like thousands and thousands of lines of code. Other examples where, for example, I've seen GitLab CI, which stands for continuous integration, which is essentially a way, and by the way, GitLab is very similar to GitHub. It's a way to have like pipelines to run every time you commit code. And GitLab CI has this functionality that is written somewhere in the documentation, which is like you can use it as a task scheduler, right? So you can run something at a specific time. And so the developers of a tool that I've used previously in the past in a company that I worked at, they actually use GitLab CI as a task scheduler. That created so many more problems than it was actually trying to solve, because every time you needed to change code in that, you needed to change the pipeline in GitLab CI. It was not really maintainable. It was not extendable. It created more problems with the fact that it was just time-based, and we wanted to run it but just by pressing a button, and all other things like that. So you can see this happening, and perhaps you have like your crazy horror stories as well. Another psychological phenomenon that happens is the cargo cult phenomenon. And the cargo cult phenomenon originally refers to Aboriginal regions that grew up in the South Pacific after World War II. So the practices of these groups, they centered on building elaborate mock-ups of airplanes and military landing strips in the hope of summoning the godlike airplane that had brought marvelous cargo during the war. And in one of his seminal papers, Steve McConnell, which is essentially a software engineering researcher from Microsoft, he describes software development organizations that attempt to emulate more successful development houses, either by slavishly following a software development process without understanding the reason behind it. And they create like big trouble doing that. Because they don't really know exactly why they're doing things that way. So cargo cult phenomenon essentially refers to this slavishly following software development processes adopted by somebody else, right? Without really understanding why. Another psychological phenomenon that happens is confirmation bias. Confirmation bias is a tendency to search for or interpret or favor and recall information that confirms or support one prior beliefs or values. This comes straight from Wikipedia. It is a very important type of cognitive bias that actually affects how we think. And you can see that very, very often in the media, in how people react to things. It's very, very hard. It's very human and distorts evidence-based thinking and decision-making. So essentially, people will try to confirm what they already think it's true, even though they receive completely conflicting information with what they already know. And that is unfortunately a fact of being a human, so you will find it anywhere, even in choosing tools, if not for more important political reasons. And the other thing that I would like to point out is that, well, times are changing and the needs of data scientists are evolving. So in most companies, it's not enough to just build a model. This is often seen as a problem by data scientists, but it actually could be reinterpreted as an opportunity. So as data scientists, we have the opportunity to show that it's possible to achieve not only the building of the model, but also productionizing the model without spending too much time on the productionization, for example, of the model itself, by choosing the right tools. And so how do you actually choose the right tools? Well, here is where your investigative mind, which you probably have as a data scientist, comes to play. Well, you need to investigate the reasons behind certain decisions. They're often written in the documentation. So you may have like a philosophy document or FAQ, frequently asked questions, or an about us, or something like that. And if it's not in the documentation, it may be, you can search some blogs, you can search some YouTubers, and worst case scenario, you can always try the tool and see for yourself what kind of philosophy is behind it. And this is very important because you need to understand, and here's the design. You need to have an eye for design and how tools are designed, and not design, in the classical UI sense of things, but actually how decisions are made in order to design a tool. So design in a much broader sense. And so try to investigate the tools and try to really understand what is the philosophy behind it and in which areas do they perform better than others. So what are the modern data scientist needs that we can combine all together and maybe figure out the best tools? Well, lately we work in teams, and it's been like that for not so long because there are not many data scientists before. And perhaps if you're still the lonely data scientist in your organization, you also saw that you have to work with other people, like other developers or DevOps. And so working in teams, we need modern collaboration tools, and we need a consistent code style. The quality of code needs to be high because it needs to be easy to read. And once we do that, well, we need to productionize things most of the time. So beforehand, we used to have the possibility, well, we used to be recruited simply because we had PhDs in machine learning, right? And not all of us do. For example, I don't have a PhD in machine learning. Well, at the time, what the companies tried to get was actually these extreme experts in machine learning specifically, and then try to integrate them in their own organization. And usually they were paired with software developers and DevOps engineers and things like that. But right now, the figure of the data scientist, I feel like, is changing a little bit. And there is a little bit less emphasis on methodologies and the latest advancements. Well, you can follow them anyway. They're not requiring PhDs in the industry, but they're requiring to productionize things. And so production is very, very important. And you need to be able to integrate with the rest of your infrastructure using Kubernetes, Docker, Dask, or whatever other cloud solution you have. And it has to be also high performance. And you need to be easy to spot problems when things crash. And keeping all of that in mind, we don't want to have things that are too complicated. So here we should always remember the Occam's razor, which literally says entities should not be multiplied without necessity, but it basically means that you should always try to find the simplest solution that you can possibly find to your problem. And this applies to pretty much any problem, but especially good for tools. So what are some good modern data science tools? And in this section, I'm going to talk a little bit about some tools that I used in the past, and then the tools that I use now that I feel they're better. And I will tell you why. Flask. So Flask is a big one. Flask is a web framework that is very, very simple. Code looks really, really clean. And it's decently performant. Everybody that productionized the model that was not a TensorFlow model or a PyTorch model or an MXNet model has used Flask. So perhaps if you had your scikit-learn models. And Flask is very, very simple to use, has beautiful code, is well-maintained, has been there forever. Everybody knows about it. Everybody recommends it. It's great. Or is it? Can we do better? So in this graph that you can see, this is a web framework benchmark. You can see Flask being not really the fastest one. So in this benchmark, you see the frameworks and then the performance. And these are requests per second at 20 queries per second in a specific configuration that you can see there. And you can see Flask, well, it performs so-and-so. It can do 1,711 responses per second at 20 queries per second. So can we do better? Well, yeah, there is all of these other frameworks that apparently are faster. And well, what do you do then? Do you try them all? Yeah, you could. But is that a very good use of your time? Probably not. So here's what I tried and what I found really, really amazing. And by the way, is in the first 5, FastAPI. So why I like FastAPI so much? Well, because it literally gives 14 times improvement in terms of performance when we're talking about this scenario. So this is what Kennedy was mentioning before. And this is very, very exciting. And you literally don't have to change that much code to do that. You don't have to write complicated code. And it kind of works very, very similarly as Flask itself. And as you can see, it's doing almost 13,000 responses per second. So this is how Flask code looks like. Very, very simple. And if you've seen what Flask can do, this is what FastAPI can do. It's great. And on top of that, it also has extra features. So as you saw before here in the apt-get/items, we're passing an item ID in the URL. And you actually get all of these APIs in documentation. So you get open API documentation for it. So it's not just a drop-in replacement for Flask, but also you get extra features out of it. Well, and why is it so fast, you may ask? Well, it's so fast because it's using a new technology that came to Python quite recently that is called async.io. I'm a big, big fan of async.io. And essentially, async IO it stands for asynchronous input-output. And it's a technique that it doesn't use threading, it doesn't use multiprocessing, but it still achieves incredible speeds when it's talking to input and output devices, including the network. And as you can see, async IO code looks pretty nice. It doesn't try to, you don't have to use so many APIs. The code is very, very succinct. And so I love it for that. Well, here's another tool that I used in the past. And it's Apache Airflow. So Apache Airflow, it's a really good scheduling tool for running tasks across multiple machines. And it has been used since forever in the data science community. And I used it personally as well. Well, what's the problem with async IO? Well, sorry, with Airflow. Well, first of all, everything in Airflow is an object. And with the way that Airflow actually makes together, makes you write the tasks and the DAGs, so the directed acyclic graphs that represent your workflow that you want to execute in multiple machines. Well, you need to write a lot of code that looks like Airflow code. And this is how actually the tutorial Airflow code is. So as you can see, there is a lot of code that looks like very much like Airflow code. So there is a lot of like declaration of things, and they have to be in a specific of steps, and they have to be in a specific format. So they're all like objects from Airflow classes. And while it worked, it's very cumbersome to use. And especially it has, you can only run the tasks at a specific time. So it bakes in the concept of time inside the task scheduler itself. And so what came out recently, which I feel it's a better solution for, especially for data scientist needs, is Prefect. So first of all, beauty of the code. This is how Prefect flow looks like. Prefect has this philosophy, which you can find in the documentation, which is, well, if it's called negative engineering. So essentially, if something goes correct, you shouldn't have to be worried about it so much. But if something goes wrong, you want to know why. So what does that mean? It means that when something goes correctly, it's essentially the case of where you're just writing your flow, so your workflows, and when things just chug along. But when things go wrong, then you want to have a nice detailed log of things. And Prefect essentially has this very, very clean coding style. It's very similar to PyTorch in a sense, because as compared to, let's say, TensorFlow version 1, PyTorch introduced the concept of a functional API instead of a more imperative style API. And what I mean by that is that in TensorFlow, you used to declare each node and each edge of a network and do it in an iterative, imperative way. So you need to tell, okay, so now there is this node, and then there is this edge, and then they connect together in this way, et cetera, et cetera, et cetera. Instead, in PyTorch, you do this just by writing simple Python functions. And then PyTorch itself takes care of the compilation to the graphs that then can run inside the GPU or the CPU, depending on what you have. Same thing for Prefect. So Prefect actually, when you're writing something in the block that begins with flow, you will essentially write Prefect code that then gets compiled to a DAG. And this DAG can then run when you run flow.run. And this not only it's a beautiful thing, but also, as you can see, you can pass Python objects around, and they get passed very seamlessly. While with Airflow, for example, you need to use XCOM, which is a specific way of passing metadata, and you need to have some specific permission. So it's also not great for security wise. Otherwise, what I used to do, it was simply to like save a file and then have like either a trigger of when that file was saved, or the fact that the previous step actually finished, in order to trigger the next step. And then the next step had to read that file. And sometimes these files are on S3, for example, so they're somewhere else. They need to be re-downloaded because you never know if these steps are going to run in the same machine or not, et cetera, et cetera, et cetera. There's so many implications of that simple functionality that Prefect has, which is data flow, simple data flow with Python code. And so that's it. To recap, Prefect versus Airflow, I prefer Prefect because it gives me the possibility to run the workflow on an irregular schedule or no schedule, because as you can see from this code, there is no mention of a date. You can essentially run this whenever you want, although you could run it at a specific date too, if you want to. And there is another problem that I haven't talked about, which is like you cannot run multiple simultaneous runs of the same workflow with Airflow because you have this centralized scheduler. Whereas in Prefect, you can run it either locally, or you can run it in a Dask cluster, or you can run it in a Kubernetes cluster. And the runner itself is the scheduler and schedules all these tasks. But since the scheduler is can be local to that specific workflow, it doesn't need to have like a concept of, okay, this workflow has to run twice, because you can simply run two of them. And so there would be two schedulers. Although it can also have a central scheduler if you want to. Not only that, it doesn't need a database. So you can run it with simply installing Python. And it's also much, much faster. So another key philosophy of Prefect is that each task could be as small as a Python function that does a simple thing. Instead, in Airflow, each task must be like a big chunk of work, because it could be that you have to spawn an entire like AWS batch server, and then it has to run in it. And so these things can take time. Plus, it introduces some delays by himself in order to have more control from the user. So Prefect encourages also like small tasks, and that makes it that makes the fact that you can have like all these tasks in parallel essentially like having a much more performant system in that way, because it will optimize it for you. Another tool that I'm really, really excited about is weights and biases. So unfortunately, there's no equivalent that was used before, but weights and biases are also MLflow. They're great tools for tracking the training steps of your algorithms and all of the measures. So it's really, really easy to use. And this is how you can integrate it in your project. You simply call 1db.init and for a specific project, and then it will actually, you insert the callback if you're using Keras, for example, in the model.fit, and then you will know exactly like what the model training is doing. And you have a beautiful dashboard that looks like this. So you can track whatever metric you want. You can also add your own metrics. It's really, really good and really, really simple to use. And yeah, so you can have all of your different experiments. And you can also inspect what was the data set that you trained on, or for example, the weights. So you can use it essentially as a tensor board, but it's a permanent tensor board, and it actually integrates with TensorBoard as well. So how do you put it all together? Well, you need to have quite a discipline into how to name files and how to structure the code. And this is one way that I come up with that I also put in a GitHub repository that you can check out. So essentially, I would separate all of the different smaller projects that you have in a data science project. So the first thing you do in a data science project is exploratory data analysis, and you just want to play with the data, and you have notebooks. And so that's why you will see here, there is a notebook directory. And you may have like the data dictionaries that the data providers provided you, or maybe you have to create yourself. You want to maybe save the references, definitely save the data. Don't save it in Git. You should use something else. Depending on how much storage you have in GitHub or in a competing solution like GitLab, I recommend you to use Git LFS. It stands for large file storage. So you can simply use Git to commit these files, but the checkout times will be instantaneous like before, instead of taking forever if you're committing a large binary file. And I recommend you to have the data organized between like steps and stages. So you have the raw data, which is the original data, the external data, and then the interim data, which is the one in between, and then the final data, which is the canonical sets for modeling. And the other steps that you want are the pipelines, because probably you want to retrain this model like another time, and you want to do it always in the same way, always consistently. And the serve part, which will probably use something like FastAPI, right? And the pipelines will probably use something like Prefect. And have separate projects for that. And for me, a project has a pip file, which is another way to install dependencies. And I feel like it's a much better way than using pip plus virtualenv. And you see pip files in here, and in here as well. And here you also see a Docker file. And just a brief mention of pip files and pipenv. So they try to copy other tools that come from the Ruby on Rails community, like Bundler, for example, if you heard about that, where essentially you have one file with the dependencies. And these dependencies can specify a specific version or have any version. And then have a separate file for locking these dependencies to the one that the developer used. And that approach is much better than having, let's say, requirements.txt with the locked versions versus the requirements.txt without the locked versions. So you could update these dependencies sometimes, and then you can use pip freeze to save the dependencies that you used with the locked version in the other one. It's just too cumbersome. So using pipenv will greatly benefit you. And I put all this together in a project that I call Cookie Cutter Modern Data Science. With one command, you can essentially create all that directory structure, and it will also put all of these great tools in the dependencies of your project. So thank you. I would like to take some questions right now. So perhaps for the questions, I will go to Slido. All right. So we have 7 questions. Something from Rishi. Which are the best platform for deployment of production models? That's a good question. It's quite in depth. So deployment of production models is quite a big topic. So it really depends what kind of models you have. So you may have something like TensorFlow. Then you should use what TensorFlow already provides, which is the TensorFlow server, TensorFlow serving, which is very optimized for TensorFlow models. It has a lot of features. You can reload models at runtime. As you may know, TensorFlow models tend to take the entire memory of the GPU, and actually, when you load them inside TensorFlow serving, then they will essentially multiplex the available RAM of the GPU, so you can run multiple models in the same GPU without reconfiguring things or partition the memory manually. And it has a lot more features than that. And you can even create your own server based on the TensorFlow serving library using C++. It's very, very performant. It's very well made. It's fantastic. For MXNet, there is MXNet model server. It's been made by the same group that makes MXNet. So it's still in AWS. It's a different group technically, but they're still in Amazon. And Amazon contributes a lot to the MXNet project. And that's a good option if you have MXNet. If you have PyTorch, it's a little bit more complicated. So there is PyTorch serving, which it's been recently released. And it's based off of MXNet model server. So it works. And you have also ONNX runtime. Well, you can essentially, if you're not familiar with ONNX, is the open neural network file format. And you can transform any deep neural network that has the operators that ONNX has into an ONNX network. And then you can run it off of ONNX runtime, which is built by Microsoft and other partners. Is very, very reliable. And it supports a lot of optimizations, even from Intel and NVIDIA. And I'm not really sure on the AMD side how it is, but it's quite good as well. And then you have other ways. Well, if you're not operating in deep learning, well, you may want to do your own model server sometimes for some specific models. So XGBoost doesn't have the default XGBoost way. So you could use FastAPI, or you could also use Seldon. So there is Seldon Core that supports the loading and the serving of pretty much any model. And this is for the serving of models, but then you need to connect things together. And to connect things together, you will need something like Kubernetes, for example. And there is a tool by Google that is called Kubeflow that essentially provides a way to have Kubernetes, but very optimized for data scientists and their workflow. And so it's a very, very simple way. You can use it from command line interface and launch the training or the serving of your models in a distributed cluster all over the world in the cloud. So yeah, I hope I answered your question, Rishi.
Carmen, if it's fine, would you like me to share the screen for the questions so that everyone
sounds
in the
great.
audience can see the questions? Just one sec. Okay, so I hope the screen's visible.
Perfect.
So let's start with, we'll start with this question. Right, so Rishi also asks, which are the best platforms for deployment of production models?
Yes, I believe this is the one that I just answered.
Okay, my bad. I'm so sorry.
No worries.
Okay, so moving on. Okay, this one. How would you, do you suggest that we can use Jupyter notebooks to organize trainings of models? If not, why not?
Interesting. So do you mean that you would like to use Jupyter notebooks for the final productionized version of the model, or just in general for training? Since I don't know, I'm going to answer both. So I would say definitely in the first phase, you will use Jupyter notebooks, and it's totally fine to organize, trainings of models in that way. I think at a later stage, it will be better to move to a pure Python code and do everything with a workflow manager such as Airflow or Prefect, and so you can or a Kubeflow, or so you could organize that in your in your production environment. But there is a way to do that, which I'm not really familiar with that Jeremy Howard uses actually to do his entire FastAI course and even the book. So he wrote the entire book, Deep Learning for Coders, with Fast AI and PyTorch, I believe. It's a really good book, by the way. He wrote it entirely in Jupyter Notebooks, and he wrote the entire course and the entire Fast AI API in Jupyter Notebooks. So there are people who can do that, but he uses a specific tool, and you should look into that. I'm not a huge fan of that, but you could try.
It could be done. It could be done. Yes.
It could be done. Yeah.
All right. So then the next question is from Andrew. He
Hi,
asked,
Andrew.
have you ever run Prefect in production before? How do you balance making choices between a proven suboptimal tech and an unproven tech that fits one's philosophy?
It's a political question. Yes, so we run Prefect at the SSG. It's not yet in production, so we'll see. But I tested it with a local Dask cluster, and it works very well because it does actually parallelize the different tasks if they can be parallelized, and it will figure out by itself what can it parallelize. If it sees that the different dependencies are parallelizable, it will do that. When it comes to the political side of things, it really depends on the company. What I mean, get the people who support you, and if they're perhaps vocal about it, you can perhaps make a change, but it really depends on the company. And I know Andrew is he's a consultant. We worked together before. So I believe you're talking about like big companies and perhaps older companies. In that case, yeah, it's a tough challenge, man. You can try to see if you find some supporters, and perhaps have like a pilot study if you can. And if you prove that it satisfies the requirements of people, then yeah, you'll probably be able to do that. And usually I would say get the requirements of people before and try to see like what is the tool that satisfies the requirements. And sometimes getting the requirements, it's not just by asking like, what do you want? Because it's a really bad technique. And about that, I will advise you to read The Mom Test, which is a beautiful book that I read right now because I'm becoming an entrepreneur, and it's about trying to figure out what people really need and really want, without ever asking that, but asking like what is their current situation, how do they deal with the problem right now, and then you develop the solution on top of that.
Okay, thank you for that. Next, I believe this question is pretty important these days. How would you suggest people manage their AI team's knowledge on both research theory and production-grade coding? How can one balance between those two spectrums?
Having 48 hours days, that would be good. But we cannot have that. So I think it's just what comes out of yourself. So it's your own passion. And you can perhaps specialize in one thing if you want. And that usually works for the better, because then you have like people who are better in that, and then maybe they will take more work in that specific space, and the team will benefit. So since this is the question about a team, I would say that would be a good way. But if you want to balance it for yourself, apart from just looking at what you want, try to see what the company needs, right? So there are some companies where you can perhaps delegate some of the production grade coding work to somebody else, and there are some companies that cannot do that. And then there are also some opportunities where you may use like more research-oriented theory, like more cutting edge technologies. Perhaps hackathons could be a great way to expand your knowledge in that. But yeah, always try to be better. I mean, that's definitely the goal for everybody. It should be, at least. And so try to see where your interest lies and what the interest of the company lies. But I would say prioritize what you like.
That makes sense. I believe, yeah, it depends from place to place, whether one side is more like needed than the other. Okay.
Yeah.
I believe we have another really interesting question over here from, I hope I'm pronouncing this right, from Teronian. His question, the question is, what's your opinion on using continuous learning when deploying ML products? Any practices that can be taken when doing these such deployments?
Right. I'm not a huge expert in that, but I would say that it depends on the exact models that you use. So you could, first of all, you need to monitor your models, and that's a big thing. So that's also why I did a patch on MXNet model server, is that to integrate it with Prometheus metrics. And Prometheus metrics, not only for the performance, but you also want to have stuff like the accuracy of the models. You want to save like the results of the models. You perhaps want to go into explainability and integrate, let's say, if you can, Shapley values and figure out why certain features were used. And so that will give you extra data that then you can inspect and see how your models are performing. And then based on that, you can make decisions on when, for example, to retrain. And perhaps you can set up a system that does that automatically as well. And there is a Kubeflow that actually supports automatic retraining and model validation and data validation. So if you put it all together and you're in the TensorFlow space, there's Kubeflow with TFX on top. You should look these up, and they're pretty cool.
All right, thank you for that. I think one of the next questions is related to this. How do you feel about Kubeflow versus MLflow? Which one is more favorable and which one can be used in certain cases where the other can't? Sheng Yisu, I think I asked this question.
Mm-hmm. Hi, Shengyi. So the two tools that you mentioned, they're very different from each other. So Kubeflow, what it tries to achieve is essentially giving you the power of being a DevOps without knowing too much about Kubernetes. And so it tailors like the commands that it has to the things that you generally do as a data scientist. So you train models, you deploy models, you retrain models, you validate models, you perhaps want to have a Jupyter Notebook server somewhere with specific characteristics. Whereas MLflow, it really tries to focus on the workflow itself and not be tied to a specific technology underlying it. So with MLflow, you could use like various different technologies, but still, for example, you train, you want to track the accuracy of the models. That's a thing that MLflow does. And it's very similar to weights and biases, as I talked before. And you could do that almost regardless of models. If you stay between the boundaries of what is supported by MLflow, or even if you don't do that, you can also save these parameters automatically and save experiments in MLflow tracking and stuff like that. But it also has other tools to make things, comma-aligned interfaces and all kinds of other things. So
right.
Which one is more favorable? Well, both. It depends on the use case.
Okay. Yes. So I think we have time for one more question. So I'm just going to, I think there was a question here which was important. Yes. So in the case for images, live videos, considering the processing time as it's a criteria for concern when deploying such models, which method would be the optimal to use in comparison with others?
It's a good question. So if we're talking about tools only, well, I would say things of the similar to Fast API, for example, if you cannot have TensorFlow serving, that would be good because they respond in very little time. because they use async IO. But if you use something more complex, which I think you would because you're using images and live videos, then if you're trying to do inference in that, use TensorFlow serving. I never used PyTorch serving, but you could try that as well. ONNX runtime, I also heard that it's really, really good. So these are for tools. I think in here, though, you may want to focus more on the actual model itself. And so in that case, well, if you're strapped for time, essentially try to use mobile versions of the same models. So if you trade off a little bit of accuracy, you can go from hundreds of milliseconds to like a few milliseconds, single digit, by using MobileNet, for example.
I see. Okay, so with that, I know we have more questions asked, but for the sake of the time for the event, I will just end the Q&A for now. So thank you so much, Carmine, for answering those questions. And I hope that if the attendees have more questions, they can reach out to you later on through your various social media handles, and they can ask the questions later on too. So thank you for answering those questions. Before we move on towards the end of the event, Kennedy, are you there? Would you like to?
Great. Thank you so much, moderator Ramesh, and also our amazing speaker, Mr. Carmine. But before we move to the last phase of the event session, one of us has requested to have you repeat the name of the book, kindly. You could repeat the name of the book.
Yes, the Jeremy Howard book. It was Deep Learning for Coders. Something fast AI and PyTorch.
Great. Thank you so much, amazing speaker, for taking us through that really highly informative, educative session full of a lot of insights. We have learned a lot. We've had our questions answered. And at this particular point, I would like to take this opportunity to really get to thank you so much. Thank you so much for creating time out of your busy schedule. Thank you so much for taking your time to share with us more to your experience, more to your work, the insights that you've shared with us. We've learned a lot. And we do greatly appreciate, and hopefully that
I think it's interrupted. Well, thank you. Oh, you're back.
Great. I believe you.
I think there are some network problems. I'm not sure.
Yeah, could be. But thank you so much, Kennedy, and thank you so much, everybody, to the organizers, and thank you so much, everybody, for coming. It was really, really great to be here and to be hosted by such an amazing organization and super, super kind people. And yeah, so if you have any more questions, you just hit me up on Twitter. It's at Paolino, so it's PAOLINO. And definitely follow also deeplearning.ai and PyNAI.
Yes.
Thank you so much.
So before we end, there's a small vote of thanks and a small announcement that we have to make before we end. So first of all, personally and on behalf of everyone here, thank you so much, Carmine. Thank you so much for being here with that amazing presentation and enlightening us with the modern ways of data science, deep learning, production level. We can deploy our models onto the web at various places, gain feedback, how to iterate over them, and so many other things that we have learned from this presentation today. Thank you so much. I would like to also take this opportunity to thank deeplearning.ai and the Alan Turing Institute. Hopefully, the beginning through this event, this will be the start of a very long and very prosperous partnership through these public lecture sessions, where the attendees and the audience will get to learn a lot about different fields, different themes of deep learning, and different topics as we moved onward to other events. I would like to thank my fellow organizers, Kennedy, Nicholas, and Griven, for making this event possible, working really hard towards hosting this event. And last but not least, thank you so much to the attendees and the audience gathered here tonight. You guys are amazing, joining from all over the world, sharing your stories. We really hope you enjoyed today's event, and we hope that you will come for future Pioneer sessions as well. A gentle reminder to make sure you have subscribed to Deep Learning AI's weekly emails, where they let us know of the upcoming Pioneer sessions happening around you. Well, of course, most of them are happening on the internet right now, so you can attend any of them. So make sure you subscribe to them, because a small announcement that we are going to be making right now is that towards the end of October, the PyNAI ambassador team will be hosting Dr. Andrew Ng on one of the PyNAI sessions. He's the founder of Coursera, Deep Learning AI, and other startups as well. And it's going to be really amazing. We're going to learn a lot and learn from his experience, what the theme will be of the event. So make sure your notifications are on so that you will know when the time comes towards the end of October, when the event comes up. And with that being said, thank you everyone so much for being here tonight. It was really amazing, and hope to see you again very soon in the next Pi and AI session. Thank you so much, everyone. Thank you.